Today we're going to go over, this is our first day on our unit of understanding the geologic history of our planet. And so today we're going to go over some of the big changes that have happened on Earth. So you should be filling in your fill in the blank notes. So don't forget you have that. You don't have to write every single thing down. Okay, so the principle of catastrophism is the first theory we're going to go over. So this idea is that all of the change that happens on this planet, geologically we're talking about, occurs suddenly. So there is no gradual change. It's just bam, something happens that's bad. And so these are going to be caused by rare and sudden events called catastrophes. And when we talk about change today, we're focusing on geologic change, or change that's happening to the planet as a whole, not necessarily change in like life or species. So this is going to be caused by fast changes that are over a large area, these catastrophes. And some examples could be massive floods, asteroids, supervolcanoes, and earthquakes. So really the main ones, the big natural disasters. And so this idea was really more popular long ago because it just matched perfectly with religious beliefs at the time. And it's not just Christianity. A lot of different religions involve a lot of the ideas of catastrophes that happen on this planet. And so it took a while before scientists started thinking more a different view that wasn't just focused on what religion said. So the opposite of principle of catastrophism, that's an even longer word, principle of uniformitarianism. Luckily, you will not have to spell that on your next quiz. Okay, uniformitarianism means that this theory states that the same geologic processes that are shaping the Earth today have been at work all throughout Earth's history. This idea was developed by James Hutton in 1795. And so he started to notice that Earth's landforms were changing constantly, that there was never a stop in change. And so the processes that would cause change, like erosion, don't just disappear over time. And this is a slow change. So if you can think about like the Grand Canyon. So if you were believing in purely the principle of catastrophism, you would think that some kind of an asteroid collided into making the Grand Canyon. But then later on, we would realize, nope, the Grand Canyon was not made from a catastrophe. It's more of a slow and gradual change over time that would be explained by uniformitarianism. So this idea allows us to think about Earth's past the way that we see the Earth happening today, because we can't get in a time machine and go back millions of years ago, but the slow changes that we see happening today, like erosion, have been at play throughout all of Earth's history. It's not like millions of years ago erosion happened so much faster or so much slower or never existed in the first place. So we're using our knowledge of today and applying it to the past. And so that's the slogan. The present is the key to the past. And so Hutton, with his knowledge that change happens slow, he was one of the first scientists to say that the Earth was a lot older than what everyone assumed it was. Again, under religious beliefs, the Earth was believed to have been only thousands of years old. But if you're watching erosion take place, the Grand Canyon alone took millions of years for the Colorado River to carve out all that sandstone that makes up the Grand Canyon. So it had to be a lot older than what it was previously believed. And so everyone thought he was crazy. I mean, anytime someone says different than what everyone believes, they like to say, there's no way, you're crazy, you don't know what you're talking about. But he was right. He didn't know exactly how old it was, but scientists believe today that the Earth is 4.6 billion years old. There is definite evidence and reason for that. It's not like it's just a number that scientists were like, that sounds good. But definitely understanding how slow it takes for change to happen on the surface is one element to knowing that the Earth is quite old. I'm going to, on Canvas, post a bunch of these YouTube clips that I have here. Here, so that you can see them if you have time to and you want some additional videos. Okay, so which one is it? Which one is correct? I keep doing that. Okay, which one is correct? Well, technically both, but mostly uniformitarianism. So most change happens slowly on Earth. But understand that we do have catastrophes. Bad things do happen, and that would have been that's what causes the mass extinctions. Okay, so mass extinctions. When we say mass extinctions, it's not like individual species that have gone extinct. This is a large percentage of life that quickly went away. And when I say quickly, it's not like in a couple of days, it's not a couple of months, not even a couple of years. It could take hundreds to thousands of years for those species to go. But if they've all gone quite nearby each other, then that would make scientists believe that there was some event that took place that knocked them all out. And we can see this in rock layers and the fossils that we can dig. You can tell when they stopped occurring and in what time frame it was, because you can geologically know how old those rocks are. Okay. So the first extinction that we know of happened 440 million years ago. It's believed to have been caused by sudden climate change. So this is a really important part of this conversation, is knowing what caused mass extinctions, because it's not, a lot of them are not from asteroids. A lot of them are changes to the temperature of our planet. And so what happened here, the entire planet got encased in ice, pretty much. Like, this was the worst. This is way worse than any ice age you've ever heard of. The entire planet iced over. And so all those glaciers that formed, glaciers are just ice on land, would have taken the water from the sea and locked it up on land. So it dropped the sea levels drastically. And this killed out 85% of marine life. And the reason it's only marine is because at this point there was no life on land. All life on this planet started in the water. Okay. The second mass extinction happened 360 million years ago. We don't really know the cause. We have some ideas, and it's a pretty good one. So at this point in time, after the Earth thawed out, land started getting plant life. And so when plants started to grow abundantly on the land, that's going to bring in a lot of new gases into our atmosphere, a lot more like oxygen. And so and that would have been a big change. So any big changes in what is happening in the atmosphere is also going to affect the water, because the water is so much of our planet. So most likely that's what happened, was that introduction to new species of life on land, creating different gases and changing our atmosphere. So 75% of life went extinct on this one. The third one is the worst one, and this is not the dinos. So this one happened 250 million years ago. So there are a chain of volcanoes underneath land called Siberia, which is like northern Russia region. And when they erupted, it caused like a chain effect. So they all went off, spewing a ton of ash and lava into the air. This would have caused a lot of greenhouse gas pollution, getting again more gases into the atmosphere that were not there before, primarily carbon dioxide. And this here, you can see these are called stromatolites. They actually are marine and they emit carbon dioxide. And so that is going to be, again, a change in the atmosphere, which is going to be devastating to the planet. And boy, was this ever. 95% of life. That's insane to know. 95%. Whew. But the positive side of mass extinctions, the 5% that lived ruled the land, and they would go on to make better, more efficient species in life that would thrive in the new world that existed. So even though mass extinctions are sad because they went extinct, the ones that survived were the species that were just most fit for this world. And so then they can thrive and flourish and do their thing until the next mass extinction, and then whatever survives after that continues on. So that is kind of the positive, the rainbow part of mass extinctions. Okay, fourth one. Not much to talk about on this. It happened 200 million years ago. We know 80% of all life went extinct. We don't know why. There is speculation that it was a volcanic events that took place, but a lot of scientists speculate that they don't believe that enough volcanoes would have caused this level of an extinction. So the last known one happened 66 million years ago. So this is the end of the dinos. And we know for sure this was an asteroid. It struck down. We found the crater. It was in the Yucatan Peninsula off of Mexico. Half of it's underwater now. But when it collided with the planet, it caused a lot of soot to go up in the air because then it caused volcano eruptions, acid rain to fall down from the pollution that was in the sky. It covered out the sunlight for years, and that made it dark and ashy and gray, so plants couldn't survive. If plants don't survive, herbivores don't survive, and if herbivores don't survive, carnivores are the last to go. So 75% of all species went extinct, including the dinos. The ones that survived, that were the fittest, were mammals. At this point, they were smaller and they didn't need as many calories. They didn't need as much nutrients, and they could burrow into the ground and protect themselves. So they went on afterwards to become the era of the mammals. Okay, so and I'll put these videos on Canvas. So the last thing to cover is that there is speculation that we are already in the next mass extinction. So scientists predict that by the year 2100, that half of the Earth's marine and land mammals will have been driven to extinction because of us, because of human activities. Either we are polluting the air, polluting our oceans, clearing rainforests for land or for medicine, for palm oil, for our processed foods, fishing, overfishing, taking out more than we're ensuring can grow back. It's a really sad one on us. This YouTube video, this clip I'm going to post is a good one, and I'd recommend you watch it. So that's all that we know about the Earth's changes, at least as far as mass extinctions go.